Hello everyone. In this video we will be doing a solution of the NTA UGC NET Computer Science June 2019 question paper. Now in this specific video we will be taking the first 4 questions and we will be providing the complete solution of the entire question paper. So let us look at the very first question here. They are asking which of the addressing modes less number of memory references are required. So they have given 4 options here. The first option is immediate addressing mode. The second option is implied addressing mode. The third option is register addressing mode. And the fourth option is in-text addressing mode. So we have covered all these addressing modes in our chapter, which is Computer Architecture Organization addressing mode chapter. We have covered all these addressing modes itself. So the first addressing mode here is your immediate addressing mode. So in immediate addressing mode, your instructions are generally like this. For example, you have instruction which is move some memory reference register R0, hash 25. So in this immediate addressing mode, we generally give the value here with the hash symbol. So this is the exact value 25. So this exact value here will be transferred onto the register R0. And you can see in immediate addressing mode, there is one register reference is required so that you can store this value here in this. So structure, you say in immediate addressing mode you have some operation code and you have some address where you want to store the data. For example, here we want to move this value 25 onto the register R0. So we have some address as well as some operation code. For example, operation code is move. The next addressing mode here is implied. So in this implied addressing mode, actually the data is present, or location where you have to perform the action is present in the instruction itself. For example, you have the instruction CLC. CLC is clear carry. So in this instruction itself, it is specified that we have to set the value of carry flag as 0. We do not have to pass on which register or on which memory location we want to perform the action, because this action itself is given in the instruction itself. So generally these implied instructions are 0 address instruction, immediate instructions are 1 address instruction. A part of this we also have register instructions, or you can say register addressing mode. For example, if you have instructions like move R0, R1. So that means you want to move the data present in the register R1 onto the register R0. Again, this register addressing modes are of various types. For example, you have register indexed addressing mode. You can also have auto indexed addressing mode and so on. A part of this, you have indexed addressing mode where exact address is not given. You have to perform some computational calculations to perform the address, to find out the address. For example, if you have the instruction which is move R0, maybe R1 plus some value 05, and you go to that memory location and you want to perform the action. So what is the action here? Take the value or address stored in R1, add this value 05 onto this, go to that memory location and then perform that move the data of that memory location to register R0. So this kind of action can be performed here. So here you can see in implied addressing mode, we do not require any register reference as well as memory reference. So they're specifically asking about less number of memory references. Remember, in most of these cases, for example, here I've taken register addressing mode. Here I'm taking registers only. These require register reference. They do not require memory reference. But again, as we have to choose only one answer here, so we are going to go with option number 2, which is implied addressing mode. So this complete theory is also written here. You can also read from this. The implied addressing mode, the operands is specified in the instruction itself. For example, we have the instruction CLC, which is used to reset the carry flag to 0. Next is your immediate addressing mode, and where we use the symbol hash. So for example, we can say move AL, 35H, where 35H is given hexadecimal. So I want to move this value to this register AL. Then you have register addressing mode, where you need 2 register references. Then you have indexed addressing mode. For example, this is an example of indexed addressing mode, where you are going to give some kind of displacement with the register. So as we have to choose only one answer, so correct answer here will be implied addressing mode, because in case of implied addressing mode you do not have to specify the address of any register or the address of any memory location. Now the next question here is from compiler design subject. So it is a very straightforward question. They are asking, in shift reduce parser, which of these things are used? So if you remember the structure of shift reduce parser, it is something like this, that we have a stack and we have the shift reduce algorithm. Now this shift reduce algorithm uses two things. One is your input, from where you are going to take the string, and it also uses the SR table or shift reducer parsing table. So as you can see, it requires both stack as well as the shift reduce parsing table as well as the input buffer. All these three things are required. So correct answer here will be option number C, or you can say option number 4, which is A, B and C. So the diagram is given like this. So in this shift reduce parser, we use a stack, we use an input buffer, and we use this parsing table. So this entire we have already covered in our videos itself. Next question, this is from operating system subject, and again it is a very simple question from semaphores, synchronization in operating system. They are saying that the value of counting semaphore is 7, and then we perform 20 P operation and then 15 V operation. So if you perform 20 P operation, that means you are going to subtract 20 from this, and if you are performing 15 V operation, that means you are going to add 15 from this on this. So they are asking, after this entire operations, what will be the resulting value of the semaphore? And the resulting value of the semaphore, this is 22 minus 20, which is equal to 2. So correct answer here is option number 3. Actually this question is all exactly from the video. We have already uploaded expected questions video on YouTube. From that video itself, this question they have directly asked it. So this is the exact same question from that video, and this question is also asked in GATE examination earlier. Next is, in relational database management system, which of the following is or are the properties of candidate keys? So there are two specific properties of candidate key. First of all, the candidate key should be unique. Uniqueness should be there. What do you mean by unique? Is that, let us suppose you have taken a roll number as a candidate key. Now this roll number should not have duplicate values. All the values should be unique. For example, if you have roll number 5 and roll number 5 is associated with Akash, so again if you have you cannot have roll number 5 which is associated with some other student. So this all the values here, they should be unique. And second, it should be irreducibility. Irreducibility means you cannot reduce the candidate key any further. I mean to say, let us assume in a table you have 4 attributes, or you can say in a relation you have 4 attributes. Attributes is roll number, name, subject and marks. So if, let us assume, our candidate key is roll number and name, so candidate key is a combination of both roll number and name. So any subset of this candidate key cannot be a candidate key. So you can say candidate key should not be reduced any further. It should be the minimal, that means minimum number of attributes should be present here in this candidate key. So this is shows that your candidate key should follow the uniqueness property as well as it should also follow the irreducibility property. The correct answer here in this question is option number 3, that both P and Q should be there. So let us look at more questions in the next video.